Alright, so we're going to start with our first section. This is 5.4, where we're factoring quadratic trinomials. Decided to do this as a video conference because oftentimes a lot of people have hard time with factoring, and part of it is due to the fact that they haven't, if they were introduced to it and they didn't feel like they understood it, so wanted to spend a little bit more attention focusing on that. So let's start with an example, and literally factoring a polynomial just means to transform a polynomial into a product of two or more factors. So you've been working with distributing binomials and such in previous sections, so from here now you're trying to sort of do the reverse. So if you look at something like x squared plus 7x plus 10, our goal for this is to factor this into two binomials. There's various ways to do this. Some people can just look at this sort of thing and if you ask yourself the question, what two factors multiply to give you 10 but add to give you 7, some of you could figure that out right up the top of your mind. So of course you know that 2 and 5 multiply to 10 but yet add to 7. There's a more surefire way to do this that I wanted to teach you for all of you who think factoring is some sort of magical thing that you can't do on your own. So if you take 10 and you factor 10, remember always that one pair of factors can be 1 and 10. But if you do a factor tree on 10, you'll find that there's 2 and 5, and those are your prime factors. I like to circle my prime factors after just so that I can see them. After you come up with all your factors, you can make a list of combinations of 2. So sometimes you might have more than one factors. In this case, of course, you don't. But if you look at 1 and 10 and 2 and 5, then you can look at these two sets of factors and then ask yourself which ones add to 7. And of course, they're all going to multiply to 10 because you determined it that way. So here's your factors of 10. So obviously, once we see that 2 and 5 is going to be the case, you just simply make two binomials where you have x plus 2 and x plus 5. I'm going to do just one more example so that you can see that too. So the next example I want to look at is something like so if we have something like this, how are we going to do this? Well, I would factor out my 20. So I'm going to look at 2 and 10. 10 breaks down into 5 and 2. So when you list your sets of 20s, you can have 1 and 20. You can have 2 and 10. You can have 5 and 4. And you can have, and that's all the possible combinations, right? So if you look at these three combinations, then what are you stuck with? So which one? Again, I want to make sure that you're asking yourself the question. The question you need to ask yourself is, what two factors multiply to give you 20? But of course, we have determined these to be the case, but add to give you 21. So if you look here, of course, the two that are going to add to give you 21 is 1 and 20. So you simply add 1 and add 20. And of course, you can always check your work. If you're not sure that this is correct, what are you going to do? Well, just FOIL it out, and that tells you whether or not it's true or not. If you FOIL this out, you're going to get x squared, and then you have plus x, and then plus 20x. So that's, and then 1 times 20 is 20. So you're left with x squared plus 21x plus 20, which is exactly what we wanted. If you have any further concerns, as always, be sure to see my office hours. Okay.